Yeah, so thank you everyone for joining today's, and we have a special guest from VeloDB, and sorry. First of all, let me introduce myself. My name is Adam. I'm from We Cloud Data. So you may join our session before, and we do constantly post different events on the Meetup. And for today, we have a special guest from VeloDB, and introduce about the new AI search features in Apache Doris. And if you are the first time to join this session, just let you know we will post recording on YouTube. And if you like this session, we will recommend you subscribe our YouTube channels, and you can keep updated on the newest topics. And also on the Meetup, I think we run it's like every 1 month or 2 months, and I believe there will be lots of new topics, new techniques being introduced like constantly, and you can just join these sessions and keep your skills up. Yeah. Thank you, Kevin.
All right, thank you, Adam. All right, let's dive right in. My name is Kevin Chen. I am the principal product manager for VeloDB, focusing on our real-time analytical and search database. For today's discussion, we are going to first just get to know little bit about VeloDB and Apache Doris for those who may be new to learning about the project. Very exciting. I wanted to kind of recap on the Doris 4.0 announcements and how we're going to be able to help you get started trying out some of these new features, VeloDB. And then we're going to dive into a very exciting use case involving ByteDance, who is actually one of the partners, community contributors to one of the highlight features that we have for 4.0, and how hybrid search is going to really help with context engineering at scale with cost efficiency. Finally, I'll share a little bit about how you can try these features that you see today, and as well as more ways to learn more about the release, about Apache Doris, about VeloDB, and then we'll have some time at the end for any questions that may come up. So to really get started, just a quick introduction. So VeloDB is a real-time analytical and search database. So really kind of taking on multiple sets of workloads and unifying that. It's founded in January 2022 by the creators of the Apache Doris project. So we have many of the PMC members, the committers, and we're actually based in Singapore and Sunnyvale, which is where I sit right now. And we engage with the communities. If you want to get support on open source, if you would like to work with us to contribute, like the case with ByteDance, and about what I'm going to talk about today, or partner with us events, I'm happy to engage. Please reach out. Just to kind of give you a quick overview, VeloDB is a database. That means it has a query engine and a storage engine. So all of this makes it so that we can query data that are under our control, as well as data that are stored in other external sources, such as tables on S3, catalog by Open Catalog, and so forth. And as I mentioned, we support a wide range of workloads. Just a bit of quick note on Apache Doris. So this is the open source project behind the company. It is a Apache top level project, and it has been gaining a lot of traction. I think we're almost at 15K GitHub stars, so very exciting. So this has actually gone increased furthermore this year. Across the globe, there are about 5,000 enterprise users that use Doris for various different workloads and use cases, and there are over 700 plus contributors. So it's a really rich ecosystem, and we're really hoping to bring that to North America and Europe to really strengthen that community as well. And you can see some of the logos for those companies who are already using Doris. And many of them contribute to the project or work with VeloDB for their particular use cases. So now that you got a little bit of taste about what is VeloDB and what is Apache Doris, which is a real-time and hybrid database, I'm going to talk a little bit about why Apache Doris 4.0 is super exciting. This release was actually announced in the open source community about a month and a half ago, and I'm proud to announce that as of today, the Doors 4.0 functionalities are live with VeloDB. And I'll talk a little bit at the end about how you can quickly get started using Apache Doors 4.0 even if you have very minimal experience setting up containers and so forth. Because this is available on SaaS, you can get to these features with just a few simple clicks, and you can really get started experiencing and building with the new capabilities. So first, let's kind of just do a recap of what are some of these capabilities. And these capabilities are very, very relevant to the use case discussions around context engineering that we're going to have later in the presentation. So let's get familiar with some of these things. The first thing that is really you're going to notice a theme is that with Doris 4.0, we're really expanding the use case and the capabilities to support AI. We always had some integrations such as MCP servers so agents can interact with us, but this step of adding vector search and really kind of integrating that into the entire experience allows us to do much more. And on that note, there are two things. The first thing is vector indexing and vector search. So this is now fully supported. And in addition, you can now combine vector search with a lot of the existing search capabilities that we already have, really, really making it a robust retrieval systems. The second thing is AI SQL functions. A lot of times you may use Python to serve as a glue to be able to coordinate and orchestrate the different LLMs, different embedding functions, chunking functions, vector stores, relational stores, and so forth. Now you can actually interact with all of these different LLMs and other AI tools with SQL from within the database, really simplifying how you build things. So instead of having to work with multiple languages and coordinating across different environments, you can start to do a lot of this in a single environment. A couple of other things to really make this experience really, really rich for search is the fact that we're adding a brand new search function. So extending on what we already built around search, now making it easy for you to, again, to perform the same sets of definitions in a single environment and context. Now, I know the top line and the highlight of the Doors 4.0 is really around vector indexing, vector search, and the search function. But there's a couple of other things we added that I think are also related. One of the things that we understand folks using Doors may have struggled before is batch processing. A lot of times you may have to use a different tool to get data into Apache Doors. Maybe that be Spark, maybe that's a Streamload. But for streaming data, but with ETL and especially batch, it may always be challenging because of lack of disk spelling. So if you were trying to ingest a large amount of data in a batch before and you run out of memory, it can be kind of challenging to deal with. With 4.0, we're introducing disk spelling. So the fact that if you're now trying to load a large batch of data into Doris, it will now be more robust. It will spill to disk. The ingestion may be a little bit slow for those batches, but it will run to completion, saving you a lot of the headaches in terms of getting data into Doors. So as you're kind of building AI applications and retrieval systems, getting data into Doors, whether that's structured or unstructured or semi-structured, is a lot easier. And last but not least, we're always focused on performance. We started our journey as a real-time database, so we're always making sure that our query latencies are continuing to improve, that we're always improving performance to make sure that it is, of course, top of the line in terms of the capabilities and offerings that are in the market. So this is a high level of the Doors 4.0 features. There is also a launch blog that was published this week highlighting these in more details. So if you wanted to learn a little bit more about these features, feel free to take a look at the blogs on our website to learn more. So now that we got an understanding of some of the cool capabilities that came out of 4.0, let's get to the use case discussion today. So today, I'm going to talk about how hybrid search is really going to revolutionize context engineering. And I want to be really specific about context engineering. And I think there's a lot of things that goes on here. But at the end of the day, it's really about providing large language models with the necessary context so that it returns a humanized answers that is useful, relevant, and trustworthy. And context can comes in many different forms. In this diagram here, this is actually one published by Anthropics. There are things such as instructions, domain knowledges, reference documentations, message chat histories. But at the end of the day, you can always think about these as data. And in many cases, a lot of these data are still text. And that requires you to query this knowledge store and data to extract the relevant context to the prompt for a user and ultimately merge that context and that data with the prompt for the LLM. In a simplified term, this is essentially what retrieval augmented generation is, and that is where we're going to focus our attention for today, specifically around the retrieval portion, because that is the part where a lot of tax is being paid, because you have to actually search through a corpus of data, and this data set can be relatively large. One of the things that is a kind of a technique that was invented a long time ago, actually was for marketing, that are used now is similarity searches. And that's where all the vectorization, clustering comes from. So today we're really going to zoom in to this search and query area and talk about the issues that come up when things get really big at scale. And what are some of the things that you can do to mitigate those issues? So when we're talking about this knowledge source, some say, well, we're thinking about this in terms of vectors. You can take certain documents, you can take media files, you can take whatever that may be, and you're representing this in an n-dimensional space. And in many cases, if you have a lot of document, let's say 100 million document in the case of ByteDance, you end up with billions of vectors. So let's say there are a billion vectors that we're working with here. And you're going to have to search this corpus of knowledge to augment a prompt so that it delivers relevant context that gets then fed into the LM so that we get the answers that are useful, relevant, and actionable. So a couple problems happens when you're looking at things of this scale. If you're using just pure vector search, for example, the hierarchical navigable small worlds indexing, you're going to have to deal with the fact that this is going to require a lot of memories. And I'll explain exactly how much are we dealing with in a bit. At the same time, if you want to optimize for performance, one of the frequently used techniques in database is database sharding. You take one giant table or data set and you chunk it up into pieces and you essentially run your statistics on those chunks. It will make your query run faster, but in certain cases, you may have accuracy issues, mostly dealing with BM25 and rankings of the relevancy. And at the same time, there's often the trade-off between accuracy and performance because you can always use bigger dimensions of vectors. You can always throw more memory at the problem to get that speed. And you can always use different techniques to scan the data so that you can always get accuracy. But if you want cost, minimizing cost, you may have to sacrifice some of these things. And it's a constant trade-off to kind of figure out what is the best balance of things. So when we get to things of this scale, these are some of the things. And I anticipate that over time, we're going to see more situations with these scale because knowledge store is always growing. Even when we're using smaller models, your corpus of context will always be growing if you want relevancy and keeping up with the fast changing nature of the world. So let's dive into some of the problems. So first thing first, why the high memory usage? Well, when we're talking about HNSW indexing, there's not only the raw data, the raw vectors, which also takes up a lot of room. In this case, for about 1 billion vectors, we're looking at about 3 terabytes of memory. And then there's also the graph constructs of all of those vectors, which is actually more than the vectors themselves. So if we actually just quickly look at how much memory this actually takes, it's about 10 terabytes. For 10 terabytes, for those who may be familiar with cloud services, if you're oftentimes provisioning extra compute so that you can even have this much memories attached to the servers. Just by looking at the sheer hardware alone, this can run $20,000 to $30,000 a month easily, if not more. And now we're talking about a retrieval system that is in the 6 digits. It's incredibly expensive, and we're just getting started. So lots of memory equals lots of compute equals lots of hardware, and therefore cost. And that's just the hardware, not to mention what vendors may charge you for the software. Then there's the ranking stability. I alluded to this a little bit earlier, but if we look at how BM 2.5 works and how database sharding works. So let's say we have records that are sharded into different segments. And each of these segments may contain 10 million documents or records or vectors or however you may chunk up your data. And in this example, let's consider the fact of occurrences. So if we're searching for potentially a word called Python, maybe we're looking at resumes, maybe we're looking at documents that are referencing Python, they might appear with different frequencies in those chunks. Logic dictates that you want to run statistics in each chunk, and what happens is that as you run the logs of the records over the number of occurrences, you'll realize that you're going to get different scores. And if we actually calculate the BM 2.5 ranking below, you'll see that you'll get different scores. Depends on which chunks or segments that you look at, even though you're looking at the same word. This is somewhat problematic because if you have different users searching for this or searching for a different part of the knowledge store, you're going to have different relevance ranking, which creates instability. And that's an issue because you want things to be deterministic, repeatable, so that you can really trust the context it provides and therefore the responses an LLM can give. So this is a problem. And if you don't shard your databases, you have performance issues. So it's a very tricky trade-off to manage. And then finally, with similarity searches, again, we're looking at relevancies in an n-dimensional space. Oftentimes, you may not get the exact match of things. For example, let's take that Python example. Maybe we're looking for Python developers in this case, and particularly in San Francisco as a prompt. If we're doing a pure similarity searches, in the case of ByteDance, what they actually realize is that they're only getting about a 58% relevancy, and they will get responses that potentially include folks that may live in Seattle or a couple years of experiences. And this imprecision comes with the fact that Seattle and San Francisco are both on the West Coast. There's some semantic similarities between the two, hence relevancy. And it might actually get picked up in the search where, in fact, there is no relevancy. We actually care about the exact match. And this is a hard rule that we want to enforce up front. So if we know that, we can actually make things a lot easier for ourselves. Instead of going through all the semantic answers, we can filter all the ones that are not exact matches. And these are the three problems that ByteDance really face when they're trying to build a retrieval system at scale without having to explode cost. So what do they do? And how do they use Doris to do it? Well, the answer is kind of obvious and not at the same time. One of the things I hear about customers commenting about VeloDB and Doris on why they use us is the fact that we're able to do a couple of things at the same time. For example, full text search, SQL queries, and joins. And when you extend that vector, you can actually build a complete progressive hybrid search filter. So starting from the very top, if you had a billion vectors and you know there are certain things that you need an exact match for, and oftentimes we do, we can do this via SQL. If the location, let's say, is Beijing, or we need a particular word that's exact match, we can just simply filter out or select on those particular terms in a structured search. SQL is fine. In fact, it's actually the cheapest thing you can do. And then the next thing we might do is saying, well, maybe we can do a keyword map. Maybe this is where we do the text search. In which case the BM25 indexing, scoring, relevancy could be the next thing. And following that, whatever's left, we may need that semantic relevancy, and then we can look at it in vectors. And of course, there's all the re-ranking so that we can get deterministic results But when we do this in a progressive manner, we can start with the cheapest thing first. Reduce the dimensions that we have to operate in, therefore simplifying the search, and of course, lowering the cost and improving the accuracy. So let's take a look at exactly how this progressive filtering works. So one of the things when it comes to the second layer of progressive filtering is to deal with memories. So after you do your SQL search, we have to think about what to do next. And with BM25 text search, it's pretty straightforward. So we're really arriving ourselves at the vector space. And one of the things that we're able to do is to reduce the dimension of the problem space. And we're doing this with two different methods. One is looking at a inverted file index, where we are not creating a world of all of the potential vectors in a single go, because when you have all the vectors in a single environment and the graph representation and all of that, that's where we get that memory explosion, where you have 10 terabytes of memory, where 3 terabytes is represented vectors and 7 terabyte represented by graphs. But if you were to cluster the vector first, let's say in cluster of 10,000s, then you're essentially representing all of this with much fewer sets of dimensions. And then you can take that a step further with product quantization, a technique that actually came out of marketing in dimension reductions for similarity searches. You can reduce this even further. And when you combine the two, we're able to actually reduce the memory usage because of the dimension reductions by orders of magnitude in the hundreds. So let's kind of dive in to the specific example with ByteDance. So the first thing first is that they use k-means clusterings to take that in 1 billion vectors and cluster and create 10,000 clusters. So this reduces the dimension space down. And when you build the graph network on the 10,000 clusters, it is now infinitely smaller than building the graph on 1 billion vectors. And we can check the 10 closest clusters and then go from there. In the second method, because we're operating in a 768 dimensional vector space, so now we're looking at the dimensions of where the vector lives. And this can be even bigger problem when you're using 4K dimension spaces for extra relevancy. And what we're doing here is saying, well, we can split these vectors into 8 subvectors with 96 dimensions each. So now we can look at a smaller number of dimensions. So instead of 768 dimensions, we can look at 96 dimensions that are split into different vectors. And this all has to do with the memory usage, because previously, if we were to store all of this, it'd be essentially 3072 bytes. But if we were to do product quantization by dividing into a subvectors, and then we're now looking at fewer bytes. Each vectors can be essentially a code block, and that could be represented with 1 byte. And if each subvector can be represented by 1 byte, all of a sudden 3000 bytes became 8 bytes. And therefore, the 10 plus terabyte memory reductions, because you have to keep all of this in memory as you're searching through, or else this is going to be even slower, will only require 500 gigabytes of memories. Because we're not only reducing the vector space representation, but also the dimension space representation. So this is a particular technique that we can do to reduce the memory usages when we actually get to the vector search. But there's also another problem that I talked about earlier, and that is re-ranking instabilities with database chunking. Um, a technique here, and this is a problem that was actually complained by many. So if you look on Hacker News, for example, people commented problem with BM25 and a database, right? We're in a database. You're going to have problems with sharding, and you're going to have problems with different users querying and getting different ranking results. Microsoft includes this in their documentation about score variation. So this is a very known thing. But supposedly, we're able to use global indexing because of our ability to quickly scan through and create a global index on all the chunks. Now, instead of using a different ranking score, IVF score for different chunks, you use the same one the ranking score is now stable because the way the VM25 score calculation are now using the same terms. And this only adds about 50 milliseconds of latency to the entire workload, but you're able to get ranking stabilities. And this has to do with Doris's particular way of able to cleverly scan through the data sets and the indexes that it has. So what happens? What's one other thing that we can do? Well, as you see on the progressive filtering, sometimes vector search may actually not be the best way to finish the bottom of the funnel when we get to the end. If you're only left with 20,000 vectors after we perform our SQL search, after we perform our full text search, you may actually not need to do a vector search at all because you could simply fit all of this data on your L3 cache and you can prefetch all that data quickly. So brute force is okay. In the case with ByteDance, we figured out that when there's less than 50,000 vectors, it is actually faster just to do a brute force scan of the remaining and then take the results from there. Obviously, if you go through these filtering, then you're still left with a relatively large amount of data left that you have to search through with vectors. We defer to vectors. So very simply, we can kind of say, hey, if there is more than 50,000 vectors, use the vector index to perform the search. If it's less than 50,000, just brute force it. And I anticipate that this may get more popular as CPUs improve over time, as we kind of figure out better techniques for reducing the dimension space and the amount of data that's left that we have to work with at the end of all of this. So let's put all of this together. When this was all started, we made the assumption that we can use a pure vector search systems to perform this context engineering and knowledge store to support generating content. But through progressive filtering, in this particular situation, we're able to deliver 7 times faster search speeds compared to pure vector through the different progressive techniques. We're able to use 20 times less memory than pure HNSW because of the techniques that I described with k-mean clustering and dimension reductions. And surprisingly, accuracy also improved because we're able to be more precise with the way that we're actually filtering out data. The actual accuracy is actually better. And all of this is running on one single server instead of 20 to 30 node of compute. So massive orders of magnitude differences. And you can look at how the time breakdown and the latency breakdown. The actual vector search only took about 100 milliseconds, the keyword search 200 milliseconds, and the re-ranking and the structuring filter only added 100 milliseconds. So overall, a relatively small percentage of the overall runtime for this particular search. And you can see the actual memory usage, again, much lower. And of course, the scoring and the nodes accuracy for both pure keyword search and pure vector search are both lower than the combined hyper search because with pure keyword search, you're missing semantic informations. And with pure vector search, you're missing exact keyword matches. Combining the two with SQL will give you best of both worlds while being more efficient. So, a few key takeaways. Pure vector search breaks down in production at scale because of the memory costs and lack of precisions. And there are ways that you can make this better with larger dimensions. You can always use different vector indexings and different tuning techniques, but oftentimes it is still very hard to get away from the memories and the re-ranking and the optimization trade-offs you have to make. It is always better to use the cheapest search first, and oftentimes that means doing structuring filtering first, then progressing to keyword search, and then really saving the most expensive last so that it is fit for purpose for what it needs to do. And some of the engineering breakthroughs involve the table level BM25 for stable rankings. We're using global statistics using IVF indexing with product quantizations to reduce memories, and then sometimes adding a little bit of brute force into the query and search on when using indexing don't make any sense anymore. In this case, although you see that there are additional complexities with hybrid search, the gains from this additional complexity is often worth it. And if you were able to do all of this in a single database, it is actually not more complicated because you don't have to move data from different sources. You don't have to orchestrate across different databases. It is just actually much easier to do because it is all in the same place. However, the fun doesn't really stop here as well, because if we kind of think about what are the potentials to go from here, supposedly in the next step in your context, you need to have exact deterministic answers to questions where the knowledge and the information is not stored in documents or text. What if it's stored in a structured table? And that you also need to combine the output of your hybrid search with other structured information. Well, luckily for us, VeloDB and Apache Doris is excellent at joins. And you can immediately join, you can have the chunks, knowledge store, and the context informations, as well as the deterministic source of truth and real data in the same place. And you're able to join the data across the two, allowing you to actually get relevant, precise informations with the context informations without having to move data to different databases or federate queries to other data sources. So it can get incredibly interesting when you have to do these kind of relational analytics on top of similarity vector, or in this case, hybrid searches. So something to think about as we progress, and hopefully folks build something cool. Additionally, if you're building AI applications on top, we have the AI functions that can be called directly from VeloDB. And also, for those who are wanting to learn a little bit more, here's a screen with the informations for you to get in contact with our Slack channel or check out some of the blogs that we have. Or if you're ready to get started, sign up for a free trial. As of today, the uh, Apache Doris 4.0 with the hybrid search capabilities is live in US East. If you find the core version 5.0 and create a warehouse, you can experience those capabilities today as well. And you can get started by scanning the QR code on the screen to get started, or go to our website and sign up for a free trial. If you're interested in learning a little bit more about this use case, we also have a blog post that have been published this week about the situations with a little bit more of the process that ByteDance went through. And of course, there's the launch blogs if you want to learn more about Apache Doris 4.0 and VeloDB. Thank you for your time, and I am now going to take a look at chat to see if there are questions.
Hi, can you hear me?
Yes.
Okay, so you probably already answered this. I did get slightly disconnected about, a minute or two ago. But I'm curious about this product because I have a RAG system that I've built recently and running into the same kinds of problems that you discussed that you've basically solved with Doris. I'm curious, is Doris a tool that I could integrate with my existing RAG, or is it something that would replace my existing RAG?
Oh, great question. So, if you already so RAG is just a system, right? So really, so what I'm really interested in is, are all of these,
There's
if these are just pure vectors, you can actually just load them into Doris. So in essence, it is replacing your knowledge store. But if you already built your chunking, embedding, and pipelining, those all can be reused. Those are not new. This is purely just a data store that stores all of the different chunked up vectors as well
I
as
see.
structured data. Yeah,
So I could use it to replace like my Chroma DB or my face.
exactly. Yes. Yeah, you can replace, OpenSearch, you can replace Postgres with this, you can replace Milvus, Chroma, etc. Yes.
Nice, awesome, awesome. And is the cost plans for storing in SaaS, is that something that you've discussed, or I should just go look online?
It's all transparent online. There's actually a pricing calculator on the web, so you can take a
Awesome.
look. There's actually two ways of doing this. You can get storage from us, which we will manage, or there's a model where you can actually deploy the product's BYOC, which you would own the storage, and that's yours.
Nice, nice. Yeah, I'm really interested. I think that's I'm sure you already know, but building RAGs, there's so many aspects to it. To you could specialize, and when it comes to the data warehousing, some of the requirements that I've had was that clients want to be able to query their database with an LLM, not necessarily just text data, structured or unstructured. And so it seems like Doris is a solution that might be able to bridge the gap in being able to integrate existing SQL databases, tables, and then querying against. Is that correct? Is that in line with
Yeah, yeah,
the
that
product?
is correct. That's actually one of the, what I hear the most from our users, which is, I ask them why are you so interested? It's because they can actually perform structured SQL queries on existing tabular data with full text search and now vector search, so that in a single place they can do all three at the same time. Yeah.
Awesome, Kevin. Is there a way that I can get in touch with you or maybe one of your team around like integration questions I may have? Or
Yeah,
is that
yeah.
like a consulting thing that I have to pay a price to do starting, or how does that work?
Uh, we're actually kind of so there's a couple way of doing this. You can find me on LinkedIn. You can connect on the Doris open source Slack channel. You can book a meeting with us on our website, which we can have folks reach out and talk to you. I think that might be the easiest. So whatever works easier for you, we're happy to book some time and chat. Yeah.
Awesome. I'll definitely join a Slack channel. I'll go ahead and create an account to do that. Are you also on Discord or not Discord?
I'm on Slack, but I think if you send an email through the VeloDB site, like if let me just kind of go back a little bit, maybe oops, yeah, like right here.
Oh, got
Um, yeah, just take a picture of the screen.
it. Yes, I did. Kevin, thank you so much. It was quite an informative presentation today. That's all the questions I've had for you right now.
Oh, well, thank you. We have time for other questions. Anybody else have any other questions?
Hey, hi,
Oh,
Ishwar.
Ishwar. Is that Kieran?
Yeah, Ishwar Kiran.
Ishwar and Kieran? Hi.
Yeah. Hey, hi, hi, hi. I was just curious, how do you, for the backup and recovery strategies for the vector index as compared to traditional data? How do you handle?
I actually don't know that off the top of my head. We haven't really talked about backups, but from a commercial standpoint, we have pretty robust backup strategy for Doris. I'm happy to kind of discuss specifically in terms of how to do the migration. We actually have customers that essentially just, use either like stream load, CDC load, or sometimes for like observability use cases like Logstash to do different backups there. But for the vector backup, I'll have to get with somebody technical because this is such a new feature. I hadn't really encountered many situations where we need to do a backup restore just yet.
Okay, okay, that makes sense. Okay, okay. And I have a question for you. Well, how can I contribute with you? Like, I'm recently graduated. Have around 1 year of experience on AI LLMs as an AI art tech.
Yeah, so join the Apache Doris Slack channel and you can find Kevin Shen or find me on LinkedIn as well or VeloDB LinkedIn's and just reach out. We're pretty active in all of these channels and we're pretty active in the open source community as well. So that's definitely one way to engage with us in terms of what we could build together or otherwise. Yeah.
Okay. I don't see your LinkedIn over here. Uh,
I would say use the Doris the
okay.
Doris Slack channel would be the best place. We are
Uh,
trying, yeah, we are pretty active there. Yeah, and there's also a help section, so you can ask questions there as
mhm.
well. Yeah.
Sure, 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 sure. Nice. Thank you, thank you. Uh, Okay, right now only these questions. I have a lot of questions, but you need a lot of time to explain it.
Yeah, like we're always happy to chat, so we can always book time to chat
Okay.
other in other sessions as well. Yes, but thank you so much for attending. I love the interest and the engagement. This is excellent.
Thank you. Thank you.
Yeah.
Yeah. Uh, I can see I have gone through it. I have a lot of integrations questions too. Can I ask that?
Yeah, yeah, we have time. Yeah.
Okay. Like, what are the models that are which are already been pre-integrated with, like OpenAI or Core? What are the pre-embedding models?
Yeah, so you get to pick your own embedding models in that sense. So
Okay.
yeah, that's completely that's how you kind of chunk your documents up if you want to set particular number of characters and the way that embed into the vectors,
Mhm.
whatever you like, essentially. Yeah. And if you care,
Okay.
if you want to learn about other integrations, let's go
Mhm.
back to this view just to kind of show you what are some of the other integrations, because there are so many different things that we can kind of integrate with because of the diverse use cases that we
Okay.
support. So, we support transactional databases. So if you have structured data that are coming from MySQL, Postgres, Oracle, etc., we have
Mhm.
robust ways to CDC that data or into VeloDB. We are also compatible with data lakes and data lake houses. I know a lot of times the data that you use are in a data lake and catalog with an open catalog. So if that's the
Mhm.
case, we can also get access to that very easily. We can connect to the catalog directly, and you're basically doing transformations in place. So ELT in place, and we can basically query all of that data with pretty good performances, in my opinion. Same
Okay.
data, same thing. Kafka, Red Panda, Confluent Cloud for first-class
Okay.
citizens supporting all of that. And of course, all of the transformation and orchestration tools as well.
Okay. Can I use this PyTorch and TensorFlow for the custom deployment and the things for the UDP embedding?
That I am not too familiar with off the top of my head, unfortunately.
Okay.
Yeah.
That's cool. I like it because it supports most of the queries and the ingest, right?
Yeah, yeah, no, it's a pretty interesting option for those people who have diverse needs with their
Mm-hmm.
data. Yeah.
So it's already stores the data in existing pipeline, right? Like Kubernetes flows.
Yeah, I mean, like, yeah, so it depends on if the data is owned by us or not, because we can operate with data that are internally owned by us, because ultimately we started off as a real-time analytical database. So what that means is that we can basically query and run analytics on the data, second after it's been ingested, and the ingestion process is also exceedingly fast. So data freshness is really around that 1 to 5 second range. And what's really cool is that we actually do index load fairly well. You can actually see some benchmark results on Apache Doris for both vector searches as well as loading the indexes. I think it's quite because of the real-time nature. The actual data ingestion for vectors is also very fast.
Okay.
Yeah.
Okay. I think I'm bothering you.
Hey, we have time, and you have questions. Happy
Uh,
to happy to answer them right now.
yeah, the final question I would ask. Can we implement multiple hierarchies in this multi-hop like retrieval systems?
Can you elaborate that question a little bit?
Let's say to develop a RAG, we just use multiple hierarchy for the multiple retrieval patterns, right? Natively.
Yeah, so that's what we did here, right? We basically used different search methods to perform that retrieval. So ultimately, it's really how you
Mhm.
define the retrieval orders. So for example, like I might do like a select star, maybe I want to do like a match first, and then I want to call on an index, or I can use the search functions to kind of to handle that particular operations. Again, it's
Mhm.
really around how you write your SQLs. Yeah.
Okay. It all depends on the sequence of answer.
Yeah, it's all defined in SQL, but you're calling these functions that are doing
Mhm.
other search methods. And if you just want to do pure search, you can do that as well.
Mhm.
Yeah.
Okay, got it, got it. Okay. Thanks for your time, Kevin.
Yeah, happy to answer questions. And
Okay.
yeah, and I don't see there are other questions. So last thing,
Mhm.
check it out, get the preview instance, play with it, and let us know how to make things better.
Okay, I just want to contribute to your, your team. How big is your team?
So VeloDB is actually pretty large. I think we're about almost 200 people across the globe, with a
Okay.
lot of folks in Asia and a small team that is growing very quickly in North America. So myself and a few of
Mm-hmm.
my colleagues are now based in Sunnyvale. So we're in the Bay Area, we're in Singapore,
Okay.
we're all over the world.
Well, okay. Yeah. Okay. Oh, gotcha, gotcha, gotcha.
All right.
All right.
If there are no other questions, thank you
Uh,
everyone for today's
uh,
participation. Yes, go ahead.
okay. How can I join your team? Like, are you hiring by any chance?
Let's take this offline.
Okay, sure, sure, sure.
Oh, I see another hand raised. Oh, never mind. Oh,
Okay, okay.
uh, I didn't know, Zach, was that an accident or you had a question?
No, I mean, I posted a question in the chat. I just wanted to see if you had any thoughts on if there's governance patterns that exist or are coming. Just trying to compare it to the way that NiFi has Apache governance or has governance patterns. My guess is no, given what I've listened to
Yeah.
on here, but still, I just wanted to ask, for the
Just to
sake of it.
clarify, you meant AI governance, right? So like explainability, traceability, auditability, that kind of stuff?
Sure,
Okay.
but doesn't need to just be AI governance and guardrail sort of things. It
Okay.
could be regarding the ingest,
Okay.
or any other of the boundaries of the system as
Okay,
well.
let me explain a little bit. So yes, we do have governance. So there's kind of two ways to think about this, right? So there is the security and access control and governance that's within the data that we control. So basically things that come through the real time, observability, log data. Those are basically like any other databases where you can write access control policies, you can do kind of like traces in terms of like when this query is ran, who ran it, and which group they belong to and so forth. So that's kind of all within VeloDB. But what's really cool is that we also integrate with external catalogs. So if there's actually governance policies that are defined in things like Unity, very soon Polaris, we can enforce those policies as well. And then for AI governance, that's a whole different beast. And I think a lot of this is there's many different kind of threats on this one. Some of them puts in different catalogs. There's AI governance scores that kind of looks at your model and as well as sort of the some of the data that's used for those models. But those are, I would say, a bit adjacent to what we do because at the end of the day, we're a database. In a lot of the intelligence we get from other tools.
Sure. I mean, I understand that NiFi is explicitly an orchestration framework, so it's going to be extremely strong with governance. And one example for governance, is where some data comes in, on a stream, and there's a process that can intercede, check it, have policies, and maybe, for instance, not pass on the data. Now, transformations, like DBT you could argue, be intended to do that, but depending upon who your audit organizations are, and other partnerships, you might intercede on data before it moves on. Now, again, I think that pattern I just described is largely like a kind of prime example of what NiFi excels at. So I don't need to necessarily ask Velo to do something that NiFi is good at. I could just ask NiFi to do it, and then send its data on to Velo. Once it's done it. But I just wanted to explore what kinds of governance patterns, particularly sort of interceding style things, not just observability, existed with it.
Okay.
And you've done that a bit here, so thank you.
All right. Great question. Thank you. Awesome. Love the questions. Anyone else? All right, going once, going twice. Once again, thank you everyone for your time. I really appreciate you guys attending the session. If interested, check out some of the recent blogs and check out the product. Have a great rest of the day, everyone, and I hope to see some of you soon.
Thank you, Kevin. We'll connect soon.
Thank you. Bye-bye.